everyone, today we're going to be talking about triangle inequalities. Our objective for today is that students will be able to recognize and apply properties of inequalities and the triangle inequality theorem to the relationships between the angles and sides of triangles. Let's get started. Alright, so the first thing we're going to talk about today is the triangle inequality theorem. And I typed it out for you because you guys know how good my writing is on here, so I apologize. But I typed it out ahead so you guys can write it down as I say it to you. So, triangle inequality theorem. A triangle exists if the sum of the two smaller sides is longer than the third side. So basically, if we add up the two smaller sides together, it has to be bigger than the third side. And that's the triangle inequality theorem. Alright, one other thing I wanted to go over with you guys, since we're dealing with inequalities here, just in case you forgot, I wanted to remind you of which ones are greater than and less than. So first of all, this symbol right here means greater than. Alright, so when the arrow is pointed to the right, this means greater than. And when it looks like this, this means less than. Alright, so just a review on our inequality symbols. Now, if you need more time to copy down this definition or what I just wrote on your screen, go ahead and pause your video. Otherwise, let's move on to some examples. So using the triangle inequality theorem, we want to determine if a triangle is a triangle given three side lengths. So we can determine if the following side lengths could form a triangle using the triangle inequality theorem. And we want to prove our answer with an inequality. So what we want to do is identify the two smaller sides. So the two smaller sides would be 8 and 17. 24 would be the bigger side. So what we want to say is we want to say the sum of the two smaller sides, so 8 and 17, if we add them together, is that greater than the third side. So we do 8 plus 17, we add them together and we get 25. Do we get a true mathematical statement? Is 25 greater than 24? The answer is yes. All right, and I don't know if you guys remember little alligator or Pac-Man, however you learned it. All right, think of the alligator is eating the bigger number. All right, so that's the greater than symbol. Or think of Pac-Man likes to eat the bigger number. All right, and then that's a true mathematical statement. So yes, 25 is greater than 24. That is a true mathematical statement. So yes, it is a triangle. Number 3, identify the two smaller sides. So 12 and 25 would be the two smaller sides. So those are the ones we want to add together. So we would say 12 plus 25, is that greater than 35? Now when we add those together, we get 37. Yes, 37 is greater than 35. So yes, these side lengths could form a triangle. Alright, I want you guys to try number 5 and number 7. Try to do these on your own and see if you get a triangle. Remember, it has to be greater than. Equal to is not greater than. It has to be bigger than the third side. So go ahead and pause your video now and give these ones a try. When you come back, I'll have the answer written on your screen and we'll go through it together. Alright, so you should have gotten no for both of these. So first thing, we want to identify the smaller sides, so 28 and 22. We add them together and we ask ourselves, is that greater than 50? Well, 50 is not greater than 50. It's equal to 50, but it's not bigger than 50. So what we do is we draw a line through the greater than symbol so that this means right here, not greater than. So when we draw a line through the greater than symbol, that means it's not greater than the other number. So 50 is not greater than 50, so no, these lengths cannot form a triangle. It has to be greater than the third side. Then over here, the two smaller sides, 12 plus 11, we get 23. 23 is not greater than 24. So no, these are not the lengths that could form a triangle. These could not be a triangle. If you have any questions on this, call me over so I can help you. Otherwise, let's move on to the next concept. Alright, so now when we're trying to find a third side range. So if we're given two sides of a triangle, we can set up an inequality using the sum and the difference to show a range of possible lengths for the third side. So what you would need to do is when we're trying to find a range and we're using inequalities, what we would do is we would say that A is less than X is less than B. All right, where X is the third side that we're looking for, And we're going to say that A is going to be the difference of the two numbers. All right. And B is going to be the sum of the two numbers. And if we use this sort of formula, this inequality, we can find a range for the possible lengths of the third side. So the first thing we want to do is find the difference of our two numbers. So we would say 22 minus 14. So when we subtract those two numbers, we get 8. Then we would want to find the sum. So 22 plus 14, that's going to give us 36. And then if we wanted to find a range, we know that our x has to be greater than 8 and less than 36. And that is how we would write an inequality to represent the possible lengths of the third side, where x has to be greater than 8 and less than 36. All right, so number 11, we first want to find the difference. So we would say 11 minus 3. That gives us 8. Then we want to find the sum. So 11 plus 3. That gives us 14. So we know that x has to be less than 14 and greater than 8. And there's our inequality that represents the third side, which we call x. Now 13. I want you guys to try number 13 real quick on your own. Try to find the inequality that represents the range of the third side. So go ahead and pause your video and give this one a try. All right, so you should have found the difference is 17 and the sum is 31. So x has to be greater than 17 and less than 31, and we would write it in an inequality that looks like this. If you have any questions on this, call me over. Otherwise, let's move on to the next example. All right, now if you saw a problem that looked like number 15, where we're given that a triangle has the lengths of 15 feet and 27 feet, and we want to check all the possible lengths for the third side. The first thing we would want to do is find a range for the third side, and we want to do that writing an inequality. So we want to first find the difference of the two sides, so 27 minus 15, and that's going to give us 12. And then we want to find the sum, so 27 plus 15. That gives us 42. So we know that the third side x has to be less than 42 and greater than 12. So there is our inequality that represents the range of the third side. Now we want to ask ourselves, do which of these values fall in that range? So does 34 fall in that range? Yes, it does. 34 is less than 42 but greater than 12. How about 12? Well, no, 12 is not greater than 12. It's equal to 12, so we cannot include 12. 29. Yes, 29 falls in that range. Yes, 18 falls in that range. But no, 43 would not fall in that range because 43 is greater than 42, and we know that our third side has to be less than 42. All right, so now we're done with 15. All right, so now we want to talk about ordering angles. So the angles of a triangle can always be put in order by comparing the sides. The smallest angle is always opposite the shortest side. And the largest angle is always opposite the, you guessed it, longest side. So for example, if we're looking at this one over here and we want to list and order the angles and list them out from least to greatest, so it's always really important to read the problem and know if it's asking you least to greatest or greatest to least. If we want to order the angles from least to greatest, we want to first look at the sides and look for the shortest side because the smallest angle is going to be opposite the shortest side. So first, the shortest side is BC, so the angle opposite of that would be angle A. So angle A is going to be the smallest angle. Then we look for the next shortest side, and that would be AB. So opposite AB, opposite AB is going to be angle C. So angle C would be the next smallest angle. And then last but not least, if we were looking for the largest angle, we look for the longest side, and opposite the longest side is angle B. So angle B would be our biggest angle. So we just listed the angles and ordered them from least to greatest, from smallest to largest. All right, now we can also order the sides by looking at the angles. So we can order the sides of a triangle by comparing the angles. The shortest side is always opposite the smallest angle. And the longest side is always opposite the largest angle. So if we wanted to order the sides from least to greatest, we want to compare the angles. So first of all, we only know what two of these angles are, but we know that all three angles have to add up to 180. So if we add 103 plus 42, we add those together, we get 145. 180 minus 145 gives us 35 degrees. So we know that angle F has to be 35 degrees. Now, what we want to do is look for the smallest angle because the smallest angle is going to be opposite the shortest side. So our smallest angle is angle F, so opposite angle F is going to be ED. Now we're ordering the sides from least to greatest, so smallest angle is the shortest side. So ED is the shortest side. Then we want to look for the next smallest angle would be E, so opposite that side would be DF. So DF is the next smallest side. And then our biggest angle is 103 and angle D, and opposite angle D is EF. So side EF is the greatest. That's our longest side. And we just ordered the sides by first comparing the angles. All right, so set one, number 1, we want to order the angles from least to greatest. So first of all, we recognize that we're ordering them from least to greatest, and what we want to do is look for the shortest side because that's going to tell us the smallest angle. So the shortest side is NP at 17, and the angle opposite that would be M. So angle M is the smallest. Then the next shortest side would be side MN, and opposite that is angle P. And then last but not least, the longest side is MP, and opposite that would be angle N. And we just listed out the angles from least to greatest. All right, so number 3. I'm sorry I had to handwrite this one, but for some reason I didn't have the slide for this one. So I drew it on here. Sorry it's so messy, but you guys can get the idea. All right, hopefully on your papers it's much neater. So we're trying to order the angles from greatest to least. So key thing here is to notice that we're going from greatest to least this time. So we're listing the biggest angle to the smallest angle. So what we want to do is first look for the biggest side because opposite the biggest side is going to be the biggest angle. So the longest side is BD at 11 kilometers. So the biggest angle is going to be angle C. So angle C is our biggest angle. Then we want to look for the next biggest side. That's going to be CD, and opposite CD is angle B. So angle B is the next biggest angle. And then last but not least, the smallest side is CB, and the smallest angle is angle D. All right, number 5. Now we're ordering the sides from least to greatest. So we identify that we're going to be listing out sides, and we want to go from the smallest side to the longest side. So we want to do this by comparing the angles. And we need to know what all the angles are. So the first thing we need to do is find out what is the measure of angle K. So we can do this by adding together J and L. So 31 plus 57, and we get 88. And then 180 minus 88 gives us 92. So we know that this angle right here is going to be 92 degrees. Then what we want to do is look for the smallest angle because that's going to be opposite the smallest side. So the smallest angle would be angle J. So the smallest side is KL. So KL is our shortest side. Then the next smallest angle would be angle L. Opposite angle L is angle JK. And then last but not least, opposite angle K is JL. So that is our largest side. And there's our sides in order from least to greatest. All right, now number 7. Number 7 is asking us to order the sides from greatest to least. So we're looking for the longest side, and then we're listing them in order from the longest to the shortest. So we want to compare the angles. So if we look for the biggest angle, that's going to be opposite the longest side. So the biggest angle is angle Y, and opposite angle Y is side XZ. So XZ would be our longest side. Then our next biggest angle would be angle X, and opposite that would be side YZ. So YZ is the next longest side. And then lastly, the smallest angle is angle Z. Opposite angle Z is side XY. So side XY is our shortest side. And there's our sides in order from greatest to least. Alright, so we can also use inequalities when we're comparing two triangles together. And the theorem that helps us describe this relationship is called the hinge theorem. So the hinge theorem tells us that if two sides of a triangle are congruent to two sides of another triangle, so if we've proven that two sides are congruent, and we know that the included angle of the first is larger than the included angle of the second. So if we said that angle A was greater than angle D, so if we're given that AB is congruent to DE and AC is congruent to DF, if we know that angle A is greater than, well, we should actually write the measure of angle A. So if we know the measure of angle A is greater than the measure of angle D, then we can say that the side, then the side opposite the angle of the first triangle is larger than the side opposite of the second triangle. So then we can say that this side is greater than this side. So if we know that the measure of angle A is greater than the measure of angle D, then we can say that BC, the measure of BC, is going to be greater than the measure of EF. And that's the hinge theorem. Now, the converse of the hinge theorem tells us that if we know two sides of a triangle are congruent to, if we know that two sides of a triangle are congruent to two sides of another triangle, and we're given that the side opposite the included angle of the first is larger than the side opposite the included of the second, so we know two sides are congruent, and we're given that BC is greater than EF. So if we're given that BC is greater than EF, then we can say that the included angle of the first triangle is greater than the included angle of the second triangle. So then we can say that the measure of angle A is greater than the measure of angle D. So it's just the opposite or the converse of the first theorem, of the hinge theorem. Alright, so now let's see some examples of this in action. Okay, so what we want to do for number one is compare the sides and the angles by filling in the blank with either a less than or greater than symbol. So I'm just going to zoom in here so we can see this a little better. Now what we want to do is compare the sides. So we know that NM is congruent to JL and PM is congruent to KJ. So we know that two sides are congruent. Then what we want to do is look at the included angles. So angle J is 79 and angle N is 74. Therefore, J is greater than N, so we know that KL has to be the longer side. So this one has to be longer than PM, all right, because it's the larger angle. So KL is going to be greater than PM, and we know this because of the hinge theorem. All right, now first thing we want to do here is determine what are our congruent sides. So we know WZ is congruent to ZY, and we know that ZX is congruent to itself by reflexive property because they share that side. So then what we want to do is look at the included angles. So 53 would be the included angle over here, all right, but we don't know the other included angle. However, we can find it because we know that all three angles in triangle XYZ have to add up to 180. So we would say 93 plus 32 gives us 125. 180 minus 125 gives us 55. So we know that this angle right here has to be 55. Now because this angle right here, angle XZY, is greater than angle XZW, that means that this side is longer. So XY has to be the longer side because angle XZY is the larger angle. So the larger angle is opposite the longer side. So we would say that XY is greater than WX, or WX is less than XY. Alright, so for number 1 and 3, we used the hinge theorem. Now for number 5, we're going to be using the converse of the hinge theorem because we want to determine which angle is greater. So in order to do this, we're going to analyze the sides. So first thing we want to do is determine which sides are congruent to each other. So we know that DF is congruent to GH because they're both 16, and we know that HI is congruent to ED because they're both 25. And we know that we're going to be looking for which angle is bigger, the measure of angle H or the measure of angle D. So what we want to do is look at the sides opposite those angles. So opposite H is going to be GI, which is 33, and opposite D is going to be EF, which is 35. Now EF is greater than GI because 35 is bigger than 33. So because EF is bigger, that means the measure of angle D is going to be larger. So we know that the measure of angle D is going to be greater than the measure of angle H because 35 side EF is greater than side GI. And we figure this out by the converse of the hinge theorem. Alright, I want you guys to try number 7 on your own. Use the converse of the hinge theorem to determine which angle is larger, the measure of angle RSQ or the measure of angle TQS. So go ahead and pause your video and give this one a try. Alright, so you should have gotten that the measure of RSQ is less than the measure of TQS by the converse of the hinge theorem, because first thing we do is identify the congruent sides. So QT is congruent to RS and QS is congruent to itself by reflexive property. Then we identify our angles. So angle RSQ is this angle right here, and angle TQS is this angle right here. Then we want to look at the sides opposite those angles and figure out which side is longer. So opposite this angle is 14, opposite angle RSQ is 13. So therefore ST is greater than RQ. So because ST is greater, that means angle TQS is greater than angle RSQ. So this would be the correct inequality. If you have any questions on this, please call me over so I can help you. Otherwise, let's move on. Alright, so now we're going to be talking about triangle inequalities and algebra. So before we jump into that, I kind of want to review a little bit of algebra stuff with you guys. So how do we solve inequalities algebraically? So first thing we want to do is solve number 1. We want to solve this inequality. So we're going to solve it just like an equation, but the key thing we have to remember is if we multiply or divide by a negative number, we have to switch the sign. So if we're solving this inequality, first thing we want to do is just move all the x's to one side and move all the constants to the other. These will cancel out. We're left with 3x is greater than 21. Now we're dividing by a positive number, so we do not have to switch the sign. Therefore, x is just greater than 7. Now number 3. We want to move all the x's to one side, so let's subtract 14x from both sides. Cancels out over here. Add 26. Cancels out over here. So we're left with negative 5x is greater than, negative 14. Now we divide both sides by negative 5, and because we're dividing by a negative number, we have to switch the sign. So now it becomes less than, and we have x is less than positive 14/5. Alright, and if we were to convert that to a decimal, we would get that x is less than 2.8. And that would be our solution to that one. Alright, so little algebra review. We got to remember how to solve inequalities, and always remember that if we multiply or divide by a negative number, we have to switch the sign. All right, now number 5, we're just going to do one example of these because they kind of take a while. So please watch closely, and if you have any questions, pause your video, rewatch something, or call me over so I can help you. All right, so if the sides of a triangle have the following lengths, we have algebraic expressions for each side length. We want to find all the possible values for x. Now, since we don't know which two sides are the shortest, we have to account for all possibilities. And that's the key thing here, because we don't know which two sides are the shortest. So what we want to do is we want to account for all the possibilities. So we would say that AB plus BC is that greater than AC. That's one possibility. Another possibility would be AB plus AC, add those together, and is it greater than BC? And then the last possibility, so the last scenario that could occur, the one we haven't done yet, is if we did BC plus AC, is that greater than AB? All right, now we want to take each of these and we want to substitute in the values we know. So AB, we know AB is 4x plus 25 plus BC, which we know is 3x minus 2, is that greater than AC, which is 9x minus 5. Now we want to solve this inequality for x, so now we're just solving the inequality. Combine like terms, so 4x plus 3x gives us 7x. Positive 25 minus 2 gives us plus 23. Is that greater than 9x minus 5? So subtract 7x. Add 5 to both sides. These will cancel out. We're left with 28 is greater than 2x. Divide by positive 2, so we get 14 is greater than x. All right, now we always want to switch this around because we always want to put the variable first. So we would switch it around, put the x first, switch the sign, and then say 14. So x has to be less than 14 with this scenario. Now we want to look at our second scenario. So we plug in. We know that AB is 4x plus 25. AC is 9x minus 5. And is that greater than BC, which we know is 3x minus 2. So combine like terms, we get 13x plus 20 is greater than 3x minus 2. Move the x's to one side. Subtract 20 from both sides. 10x is greater than negative 22. Divide both sides by positive 10, so we do not have to switch the sign. So x is greater than negative 2.2. That's another scenario. All right, and then the last scenario, we know that BC is 3x minus 2 plus AC, which is 9x minus 5, is greater than AB. And we know that AB is 4x plus 25. Now we're solving for x. So combine like terms, we get 12x minus 7 is greater than 4x plus 25. Subtract 4x from both sides. Add 7 to both sides. Cancel these out, and we get 8x is greater than 32. Divide by 8. So x is greater than 4. All right, so here are our here's our 4 scenarios, and there are 3 scenarios and the 3 inequalities that occur. So we know we've got that x has to be less than 14, so we have 1 less than, and then we have 2 greater thans. So right off the bat, we know that x has to be less than 14. That's a guarantee, all right, because it's the only less than that we have. But now we've got 2 greater thans. We know that x has to be greater than negative 2.2 and x has to be greater than 4. So it has to be all of these. So because we know that x has to be greater than 4, it can't be greater than negative 2.2. So if we have 2 that are greater than, we want to think logically. If we have a number line, right, and here's 0, we know that it has to be less than 14. So we know that it has to be this way. Now we also know that it has to be greater than 4. So it has to be these values right here. So it has to be all the numbers in between. Negative 2.2 would be over here. So saying that it has to be greater than 2.2, all these values in between here will not work because we know it has to be greater than 4. So if we have 2 that are greater than, we want to pick the bigger number. All right, so this is not a possibility because we know it has to be greater than 4. Now, if you had 2 less thans, pick the smaller number, all right? So 2 greater thans, pick the bigger number. 2 less thans, pick the smaller number. So our range of values here, we know that x has to be less than 14 and greater than 4. So that would be our range of values for the third side. And we found that using algebra. So I know that was a little bit tricky. If you need to rewatch this example, go ahead. Or if you have any questions, call me over so I can help you. All right. Hope you learned a thing or two about triangle inequalities today. Any questions, call me over or ask someone, ask a friend. Otherwise, look to the board to see what to do next. And I hope that you have a great day. Bye.